All right, chapter 16, electricity, starts with chapter 16.1, titled Charge and Electric Circuits. This is definitely a chapter when you think about the stuff that they talk about in here, the lives that we currently lead. It would be nearly impossible to live a life without electricity. There are so many things in our lives, day in and day out, that we use electricity for. So in this chapter, we're going to explore electricity, electrical circuits, and we're also going to talk about the nature of electrical energy. And hopefully you learn about how electricity can be powerful and dangerous, but when you know the facts about how electricity works, you can use it safely and with confidence. All right, so like mass, charge is a fundamental property of matter. All matter has electrical properties because the atoms that make up matter contain protons and electrons, which have a charge. So remember, we learned about atoms, protons, neutrons, and electrons. Usually, the positive protons balance out the negative electrons, and it makes the atom neutral or electrically neutral. So an object that has equal amounts of positive and negative charges. Sometimes, however, as we've learned a little bit when we did our chemistry unit, we know that that doesn't happen. So when you don't have that equal number of positives and negatives, it makes the matter charged. And we actually have a unit that we use to measure that. It's called a coulomb with a capital C, so the unit used to measure electrical charge. So if an object is charged, it describes an object whose net charge is not zero. So you can see the balloons in the picture on the top there. The one on the way left, neutral, because the positives and negatives equal each other. The one in the middle, it's got more positives than negatives. So that particular object would be positively charged. And the one on the far right-hand side, we have less positives than negatives. So that object would be negatively charged. So more protons, positively charged, because remember, protons have that positive charge. More electrons, negatively charged, and then if the protons and electrons equal each other, they are neutral. If you guys have ever been shocked from clothes that came out of the dryer before, or if you've been walking in your house and you get an electric shock when you touch a door, you have experienced charged objects. And that's kind of our interaction with static electricity. So static electricity is caused actually by a really tiny imbalance between the negative and positive charges on an object. The cartoon here is showing you between your hair and a balloon. When you take and you rub a balloon in your hair, you're actually just pulling loose electrons off your hair, and you're making the balloon more negatively charged. Your hair becomes more positively charged, and then they really like each other and stick to each other, like you see in the picture there. So this science of electric charge and current is actually what electricity is. So the science of electric charge and current. When these electric charges get moving, the flow of those charges moving is what we call an electric current. So whereas static electricity is essentially referring to the lack of movement, because that's what the word static means, and that charge may build up and that may cause movement, like if you rub the balloon in your hair or you touch a doorknob or something. Electric current is actually the flow of electricity through things like wires and motors and light bulbs and other objects. It's almost always invisible, and it comes from the motion of electrons or other charged particles. And what you can see on the picture here, this is actually what we call an electric circuit. So a complete path through which electric charges flow. If we want electric charges to flow, they have to have a complete path. That is a really important part of this. It's got to be complete. If you break any part of that, those electrons don't have the ability. They're not going to jump across from one thing to another. Just doesn't work that way. So you need a complete path for those electrons to flow in order for them to go. What you see on the left-hand side is what it would kind of look like if you just saw a real thing here. This is called a switch. There's a battery and then there's a light bulb. On the right-hand side, in electricity, we use these schematic drawings that help us understand stuff better. Same exact thing, but it's in a picture that's a little bit easier to understand. There's circuits in nature, so this is natural, even though, yeah, we produce it and we use it for our lives. This happens naturally in nature, so electric eels use it as a defense mechanism. Lightning, obviously we're all familiar with that one, and then actually anytime our nerves pick up sensation in our body and then we cause our muscles to move, that is actually shockingly using electricity. So here's another picture of a circuit diagram that you can see, same sort of a deal again. You can see on the picture on the top here left what it would actually look like. And then on the right hand side, that's a schematic drawing. So it makes things a little bit easier. for us to understand. Plus, it's a little bit easier for us to draw. So you can see on the right-hand side, wires are just a straight line. Batteries, you're always going to have a long line and then a short line. The longer part of the line indicates the positive terminal of the battery, and then the shorter line indicates the negative terminal. Bulbs are kind of hard to draw. It's kind of like a squiggly line with a circle around it. Resistors, we're going to learn just in a second what those are. Resistors get a squiggly line, straight up squiggly line, and then a switch on the bottom there you can see is 2 dots. And that particular switch happens to be an open switch. If it's a closed switch, which we're going to talk also in just a little bit about, it's going to be together there. So a resistor is a device that uses energy carried by electric current. So it's going to be one of 2 things. It's going to be something that we put in the circuit to slow down current, to control it, or we want to draw the current from that circuit. So like if you plug in a light bulb, if you plug in a toaster, those things all contain resistors because they're using energy that's caused by that current. But like I said, sometimes we'll actually put resistors in a circuit to slow down the current. You got to imagine that electricity, we don't want it to just be doing whatever it wants. We don't want it to get out of control, because if that's the case, those electrons will actually cause a fire. We use an analogy a lot between electricity and water. And when you think about how water moves through pipes and maybe even moves through a system, electricity actually behaves very similarly. So just like how you have water that'll move through pipes, electricity moves through wires. So you can see on the left-hand side here the analogies. If we have a switch in a circuit, that would be like a valve. So just like you have a valve in order to turn the water on and off, that's what a switch does in a circuit, turns the electricity on and off, making that current open or closed. Resistance is going to be something that uses electricity, like we talked about light bulbs. And the water analogy would be like a water wheel. So the water is going through it, but it's going to slow down when it hits the water wheel. And then to get that push, to get the electricity moving through, we use batteries, but in the water, that would be a pump. So imagine like a pump, a water pump that's pumping water through. So we'll use that a lot. I mean, because it really is, it's kind of crazy how they do kind of act a lot like each other, even though they're completely and totally different. All right, so closed circuit's a circuit with no break, so charges can flow. So you can see in the top picture here, the switch is down. So that would mean those electrons have the ability to go through every part of that circuit. The battery, the light bulb, and the switch, because the connection is there. So that means the light bulb's going to light. If you look at the picture on the bottom there where the circuit is open, now those electrons don't have a complete path. So because they don't have a complete path, they are going to not cause a light bulb to light up because they can't jump through there. So the top one is called a closed circuit, and then the bottom one is called an open circuit. And anytime you're at your house and you're turning lights on and off, this is exactly what you're doing. You got to think about when you turn a light switch on, actually what you're doing is making it so the circuit is closed and the light is going to light up. So a closed circuit is actually on. Whereas if I go to turn the light switch off, I'm opening the circuit so that light isn't going to be on. So switches are devices that control the flow of electricity in a circuit. It gives us the ability to turn things on and off. I mean, can you imagine if we didn't have the ability to do that with all of our electronic devices? Last thing the book talks about is it talks a little bit about light bulbs, different types of light bulbs. You see in the picture here, the one on the left is called an incandescent light bulb. These are going to be phased out in the somewhat near future because they are not very efficient. Most of the electricity that goes through these light bulbs is actually wasted as heat energy. How they work usually is there's a tungsten filament in the middle of it, and that tungsten, the metal, when electricity runs through it, it heats up and it actually glows. At some point in time, that wire filament will actually burn too hot. It's going to break, and then you just open the circuit. So a burnt incandescent light bulb is you just opening the circuit is really all that happens. The light bulbs on the right, that one's called a CFL, or a compact fluorescent light bulb. They're actually filled with a gas. And when that gas is heated, or electricity goes through it, it excites electrons inside there, and it actually creates electricity.